Hi, in this video we're going to go over the physics journal about kinetic energy. So yeah, just go ahead and follow along. So the question that's guiding our notes here is if you double the car's velocity, how does that change its energy? Meaning like if you double the velocity, is that going to double the energy, the kinetic energy? Is it going to quadruple the kinetic energy? Is it going to 1/2 the kinetic energy? Like how is the velocity related to the amount of kinetic energy you have? Any object that's moving is said to possess kinetic energy. We kind of already knew that, right? That kinetic energy is the energy of motion, aka energy of motion. So the kinetic energy is proportional to the velocity squared. So basically what that means is because the velocity is squared right here, which if you recall from the kinetic energy lab, right, we had to make a kinetic energy versus velocity squared graph. And so that's where that squared came from. And then the slope of that line was 1/2 of the mass. So anyway, that's how that equation. So it's kinetic energy is equal to 1/2 times by the mass times by the velocity squared. So let's go ahead and take a look at an example problem here. So we have a 3-kilogram block slides down a frictionless table at 1.2 meters per second. How much kinetic energy does it have? So let's go ahead and switch over to my blank paper here. So how much kinetic energy does the block have? So we know the mass right here, it's 3 kilograms. We know the velocity, it's 1.2. So we know that our equation is 1/2 mv squared. So go ahead and plug in our information. 3, we got our 1.2 squared. So you can just use your calculator. Probably square the 1.2 first. So 1.2 squared. That's going to give you 1.44. Then multiply by 2 or multiply by 3. Then multiply by 1/2. And in total, you're going to get that it has, let's see here, 2.16 joules of energy. So moving along to the next one, it says if it hits a spring with a spring constant of 50 newtons per meter, how far will it compress the spring? So basically we have our like spring over here. This thing's going that way. 1.2 meters per second. How far will it compress the spring? Well, what's going to happen is basically we have this much kinetic energy. That kinetic energy is going to be transferred into elastic energy. So we got our elastic energy is equal to 1/2 kx squared. We know that we have 2.16 joules of kinetic energy. That means that now we have 2.16 joules of elastic energy because all of that kinetic energy has now been turned into elastic energy, kind of the reverse of the kinetic energy lab. Right, in the kinetic energy lab, we had elastic energy that was turning into kinetic energy. This time we have kinetic energy that's turning into elastic energy. We know that K is equal to 50. And we are looking for X. So 2.16 is equal to 25x squared. Divide by 25. So 2.16 divided by 25. That's going to give us 0.0864 is equal to x squared. Square root both sides. And you get that x is equal to 0.29 meters, which basically means 29 centimeters there. So let's go ahead and look at the next one. So example 2, we have this this roller coaster, and as we look, we actually are going to have different amounts of or different kinds of energy as we go throughout. So it says a roller coaster starts from rest, so that means initial velocity is 0 at the top, and meaning no kinetic energy at the top. Is at rest at the top of a 50-meter tall hill right here. The roller coaster has a mass of 220 kilograms. First question, how much gravitational energy does it have at point A? Okay, so first up, let's just take a moment and think about the types of energy that we have at each point. We're going to start out up here, and it has just gravitational energy, and that's it. It's up high, so that tells us that it has gravitational energy. It is not moving, right? So the velocity is 0. There's no spring involved up here. So let's take a look at where it is at B. So at B, right, it's going to have just kinetic energy. So it's not up high, so no gravitational energy. It is moving, so it does have kinetic energy. And then there's no spring at part B. Let's take a look at part C. Part C is actually going to have a combination of different types of energy. Like it's going to have gravitational energy because it is up high, but it's not going to have as much gravitational energy as it did at A because it's not up as high. That means that the rest of that energy is going to be kinetic energy, right? It's going to have some kinetic energy as well, simply because, right, it's not going to, it could go all the way back up to the top if it, if the track went that way. So it's because it's only like half-ish of the way up, it's going to, right, it's going to have some kinetic or gravitational energy, but then it's also going to have some kinetic energy because it's going to be still moving. Okay, now that we've thought about that, let's go back to A here, which is how much gravitational energy does it have at point A? Okay, gravitational energy, that's pretty easy. We got gravitational energy is mgh. So the mass is 220 kilograms. G is always 9.8, and H is 50 meters. So simply multiply those all together. 220 times 9.8 times 50. Okay, let's see here, 107,800 joules. So that's a lot of joules, but it is a roller coaster, so it does make sense that, it's going to have quite a bit. So take a look at the next one. How fast is it going at point B? Okay, so let's think about what's happened here. At point B, all of the gravitational energy we had, 107,800 joules, has turned into the kinetic energy, right? So now I have 107,800 joules worth of kinetic energy. So we got our equation for kinetic energy. We know that we now have 107,800 joules worth of kinetic energy. That's going to be, all right, we got our mass there, v squared. We're solving for v, right? So that's going to give us 107,800 is equal to 110 v squared. Divide by 110. So it's going to give me 980 equals v squared. Square root both sides. Square root of 980 is going to give me 31.3 meters per second. All right, and let's take a look at the last one. So the last one asked me how much kinetic energy does it have. So let's note that it's not asking me the speed. It's just asking me how much kinetic energy does it have at part C. So basically it's asking me, if we go back and look at what we had up here, it's asking me for that number right there. Now, what I know is that all the way throughout, I'm going to have 107,800 800 joules of energy, right? So I had 107,800 joules of gravitational energy. Then I had 107,800 joules of kinetic energy. And now together, those are going to add up to 107,800 joules. So let's take a look at this, right? I know that the total amount of energy that I have is 107,800 joules. Okay. And I also know that right, the gravitational energy plus the kinetic energy at part C, sorry, you couldn't see that, is equal to the gravitational energy plus the kinetic energy. So here we go, 107,000. Let's see, 800 is equal to gravitational energy, that's mgh. And I'm just going to leave it as EK because, again, remember, I'm solving for that. So I just want to leave it there because then I can solve for it, right? If I was to plug in 1/2 mv squared for EK, well, now I can't solve, I could solve for the velocity, but then I'd have to plug it back in, and that's stupid. I could just leave it there. So now I can just plug in, I got my mass, which is, again, 220. I got 9.8. Let's remember that the height I'm at right now is 30 meters. So I can multiply all those things together, 220 times 9.8 times 30. So that's going to give me 64,680. So now I can subtract that over. So I got my 107,800 minus the 64,000. And I'm going to get 43,120 joules is equal to my kinetic energy. And there we go. Hopefully that makes sense. As always, let me know if you have any questions. Thank you for watching. I appreciate it.